All right, guys, we're going to talk a little bit about solving absolute value equations and inequalities. So we've talked a little bit already in our class about the absolute value function and the symbol. So remember, when you're looking at or thinking about absolute value, it is the distance of a number from 0, which is why when we think about this, we do the absolute value of a negative becomes a positive, and the absolute value of a positive is still a positive. All right, so there's a couple examples here, which we'll talk more about in class, but I want to focus on this table here, and we'll do some practice problems in this video so you had a chance to practice a lot of this stuff. So the first case that we're going to look at is going to be when it's set equal to some constant. All right, so we set two separate equalities where we set one to a positive constant and one to a negative, right? And so you'll notice when you look at the graph or the solution set, there's just 2 points there, right? It could be actually only 1 or no points, but most of the time it'll be 2 points. All right, so really just 2 solutions. Now, case 2 and 3, I'll help you with those, but because you have inequalities, you're going to have a range of values. So you can notice with the solution set, right, our interval notation, and we've talked already about that union because we have 2 different sets in terms of looking at the answers for the greater than. Okay, so let's do a couple of examples of each of those cases, and then we can practice those, on your own. Okay, so this is the first one is a case number 1 example where we have an equal sign. Now, rule number 1 when you're doing this is before you do anything, you always have to isolate the absolute value symbol. Okay? So no matter, before I do anything, if I don't have the absolute value symbol by itself, then I can't do any of this stuff that I'm going to teach you, okay? Now, when it is equal, right, and you'll notice our absolute value is actually isolated, right? That's the only thing on that side of the equation. When it's equal, I'm going to put a big or, all right? And on the right-hand side, I'm going to put 5 minus 3x equals positive 12. And on the left-hand side, I'm going to put 5 minus 3x equals negative 12. All right, so you'll notice I have essentially the same thing on the left side, nothing changed there, but the right hand side, 1 is equal to a positive and 1 is equal to a negative. The work is going to feel very similar, right? We're going to move that 5 over with subtraction, get negative 17, so x equals 17 thirds. And over here, same thing, you're going to move that 5 over with subtraction, but you get x equals negative 7 thirds. So plotting it, remember like we had in the table, it's just going to be 2 points, right? I'll make this 0. So 17 thirds, that is almost 6, right? 18 thirds would be 6. So I'll say 17 thirds, 1, 2, 3. Let's say it's about here is 17 thirds to put my point. And then negative 7 thirds is a little past negative 2. So I'll put that right here for negative 7 thirds. So again, we have 2 solutions for this absolute value equality. Okay, I'm going to skip this one with the both having the absolute values and move to a couple of inequalities. Again, make sure your absolute value is by itself first. It is. And now this symbol right here is the less than symbol. So what I'm going to teach you guys is when you're doing less than, you're going to think less than. All right, and it's going to be kind of silly in class, but it's going to help you remember that when you have the less than symbol, you're going to use the word and. This is what we call a conjunction, okay? The right-hand side, you're going to copy everything the same, but you're going to drop the absolute value. On the left-hand side, you're going to make the left part of the inequality the same, but you're going to make the absolute value, make the inequality symbol be the opposite one. So instead of less than, I'm going to use greater than. And you're going to make that 7 become the opposite, or negative 7. All right, so that'll take some time to practice. You do less than, so the and tells you it's a conjunction. The one on the right, I just copy the same. The one on the left gets the other inequality symbol and the opposite of that constant. All right, now we solve. Move that 1 over with subtraction, you get 6. So x is less than 3. The other side here, move that 1 over with subtraction, you get negative 8. So x is greater than negative 4. So now when I graph this, I'm going to have at negative 4 and 3. All right, and these are open circles because you'll notice the symbols, we don't have or equal to underneath. So use open circles. And the way the signs work is this greater than, we're moving to the right, and less than 3, moving to the left. Right? Another way to remember this is a conjunction, so they're going to come together. So any values between -4 and 3, but you can't include those, would satisfy this absolute value inequality. So I'm going to just choose 0. 0 is in there. So if I did 2 times 0 plus 1, would that be less than 7? So 2 times 0 is 0. 0 plus 1 is 1. The absolute value of 1 is 1, and 1 is less than 7. So that works. Okay? Let's try the next one. Now, the next one is very similar, except we have the greater than symbol. So when you have the greater than symbol, you're going to think greater than. So greater. All right? So use the word or. This is called a disjunction. Right, 2x plus 1 is greater than 7 on the right-hand side. Notice the absolute value symbol is gone. On the left-hand side, right, 2x plus 1, and then this is going to be less than, right, the other inequality symbol, -7. So solving, we get 2x is greater than 6, x is greater than 3. On this side, 2x is less than -8, or x is less than -4. So I have the same values here of -4 and 3. They're both open circles, but watch what the graph looks like. All right, the solution set are going to be values that are less than -4, which is going to the left, and greater than 3, which is going to the right. So we'd have to plug in a value that's past each of those if we wanted to see a true statement. So I'll choose 6, right? 6 is to the right of 3. So that's going to be 12 plus 1. That's 13. The absolute value of 13 is 13. So that works. Okay? So that's how you do the greater than symbol. All right, let's do a couple more examples where we have to do some isolating first. So you'll notice that the absolute value symbol is not by itself, right? There's that -1 that I need to move over. So let's move over that -1 with addition to get 4 plus 1, which is 5. So now, I always used to tell my previous students, this is kind of like the checkpoint. You want to make sure that you get to this checkpoint. If you're not here, you're not allowed to use the words and take off the absolute value, okay? But we are allowed to. That's the greater than symbol, so greater, right, greater. I'm going to write 2 minus 7x is greater than 5, copy it. Then 2 minus 7x, switch the inequality to less than, make the 5 become the opposite. Okay, solving for these, I get -7x is greater than, subtract 5 minus 2 is 3. Now, be careful here. Go back to your days in middle school or Algebra 1. When you divide both sides by -7, you need to know that that's going to change the inequality symbol to be the other one. So this is actually going to be less than -3/7. And the other one here, move the -2 over, or excuse me, the 2 over the -2, and you get -7. Again, I do have to change that symbol, so it's to make greater than +1. So graphing here for this one, I've got x is less than -3/7, and I have x is greater than 1, both open circles. So I'm going to go greater than 1, and then less than -3/7. Now you might notice on these, it doesn't kind of like line up nicely like the other one did. That's because we had a negative in front of our variable. That caused a change in the inequality symbol. So sometimes it might happen like that, but just make sure you're reading each of these statements and you should be fine. Okay, this next one. This is isolated with this absolute value. So I'm going to go ahead and drop the absolute value and use my word, right? This symbol is greater than or equal to, so greater. I'm going to write 2 minus 5x over 3 is greater than or equal to -4. That's on the right side. And on the left side, 2 minus 5x over 3 is less than or equal to +4. Okay? Now, when we're doing this, all right, you're going to do all the algebra the same. I'm going to move the 3 over, which is going to be multiplying to get -12. Move the 2 over with subtraction, you get -14. Divide by that -5, so it's going to switch the sign to be +14/5. This one over here, do the same thing. Move the 3 over to get 12. Move the 2 over with subtraction to get 10. we are dividing by a negative. So I've got to switch the symbol to get x is greater than or equal to -2. Now watch what happens when I graph this. So we got -2, 14/5 is almost 3. Using my points here, I do have closed circles. All right, now watch what happens, okay? Greater than or equal to -2. It's going to move this way. And then less than or equal to 14/5 is going to be like that. And this is one of those interesting cases where when you look at this, right, the word or, as we've done before, was moving away from each other, right? The one above it, or away from each other, this one, or away from each other for the disjunction. So sometimes it can happen, all right, because of the way that we switch the inequality symbols with the negatives, that it may, end up being like this. But let's check our answers. Let's plug in 0. All right, 0 is in there, so it should work if we plug in 0. Let's confirm. All right, so we've got 2 minus 0, which is 2/3. And that is going to be greater than -4, right? And what I hope that you're noticing as I'm going through this is that because of this number on the right-hand side, put it right here highlighted, right? Because of this number right here is a -4, I'm hoping you're looking at this screen and thinking, wait, we do have to take the absolute value, right, when we're done. And what happens when we take the absolute value of any number? It always becomes positive. So if it always becomes positive, then this will always give a true statement, because positive numbers are always greater than or equal to -4. So actually, when we do the solutions here, we're going to have all real numbers is going to be our solution. All right, and I'm hoping that you'll notice as we do more of these that the dead giveaway is when you have that or and it doesn't match with what your graph is showing, something interesting is going on. So or, I'm thinking, should go away from each other. It's a disjunction, but this graph shows a conjunction, like an and, so something is up. If you think back, okay, take a look at that, that is what is going on. That's the interesting thing. Just be aware of that. So with that being said, if you look at this next one, all right, we're looking for absolute value of something to be less than a -3, right? We know these will be always positive, right? No matter what happens. And will we ever have a positive number? Is that ever going to be less than -3? That'd be like -4, -5. No. So even before doing any of this work, I know this is going to be no solution. There are no values that work. Now I'll show you the work so you can see what happens, but hopefully you'll get to that place where you can just start analyzing, like, okay, before I do this, is there something interesting going on? Okay, so this is less than, so I'm going to write 4x minus 7, and I'll put and there, is less than -3. And on this side, 4x minus 7 is greater than +3. All right? Okay, so let's move the -7 over with addition. So you get x is less than 1. Move the -7 over with addition, so you get 10. So x is not equal, greater than 10/4. All right, so plotting this, I have 1, and then 10/4 is, what is that, 2.5? So it's pretty close, 10/4. Open circles. Now watch what happens when you do this. Greater than 10/4 is going to the right. Less than 1 is going to the left. Now that looks like the word or, right? This is a disjunction. But if I think about the word that I used, it was and. Those don't match, all right? And we already know why they don't match, because there's actually no solution here that would ever make this a true statement, okay? So we'll try a couple more of those in class. All right, let's try one more and then we'll be finished. So we have equal to 0. When you get this case, right, with equal, I told you guys at the beginning, you have 1 equal to a positive, 1 equal to a negative. Now, 0 is neutral, right? It's neither positive or negative. So really all you're going to do is just set up 1 where you have 5x plus 15 equals 0. So there's only one answer to this. And I mentioned earlier that sometimes with these equalities, most of the time you're going to get 2 answers. This is the case where you get 1. And if this had said 5x plus 15, the absolute value is equal like a -7. This will never be true, right? Because taking the absolute value at the end would make this positive, and that'll never be equal to a negative, okay? So that would be where you have no answers. So let's solve this. Move the 15 over, you get -15, so x equals -3. So there's only one answer here, and then that's just a closed circle with no arrows moving any direction. If your symbol is an equal sign, you're only going to have dots. We're not going to have any shading or moving to the left with arrows. All right, so try some of the practice problems, and don't forget less than and greater. That'll help you with this. And don't forget, be careful or have like an eye out for those special cases. All right, good luck.